Over the past 50 years, corn is another crop that has become increasingly important across South Texas and the coastal bend. Many advances in corn genetics, production practices, and genetic transformations have vastly increased corn production over the last several decades. After the opening of the Corpus Christi Center in 1974, there was an increasing interest in South Texas corn production. The primary problems limiting corn production in South Texas were associated with post-silking drought stress, especially in the lower coastal bend, which has variable and lower annual rainfall. Charcoal stalk rot caused by a soil-borne fungal pathogen occurs routinely on corn, especially across the lower coastal bend. But its occurrence is not always directly associated with a decrease in yield. It's difficult to separate yield loss caused by drought and that caused by charcoal rot. In contrast to sorghum with charcoal rot, corn remains standing due to better stalk strength. Hybrids with weak stalk strength and susceptibility to charcoal stalk rot are rather quickly identified and removed from commercial production. By the early 1980s, there was a noticeable problem in South Texas with mycotoxin occurrence in pre-harvest corn subjected to late-season drought and heat stress. This was primarily pre-harvest aflatoxin produced by the fungus Aspergillus flavus. But there was also the occurrence of another mycotoxin called fumonisin, which is produced by the fungus Fusarium verticilioides. In addition to the drought stress component in South Texas, there is the involvement of two leaf and ear-feeding insects, corn earworm and fall armyworm, that also contribute to mycotoxin contamination in corn kernels. By 1990, it seemed as if most Corpus Christi Center research and extension specialists and county agents were involved in some efforts to reduce aflatoxin risk through hybrid screening and production practices. In the mid-'80s, collaborative research at the Corpus Christi Research Center was also initiated with Texas A&M corn breeders at College Station and later Lubbock. The Texas Corn Producers Board became instrumental in providing research funds for corn improvement and mycotoxin research initiatives. Through the efforts of corn breeders and other scientists, many local research efforts also had statewide, regional, and even nationwide mycotoxin research components. Genetic advances were made and are ongoing to develop and identify higher-yielding, mycotoxin-resistant hybrids with better adaptation to Texas and South Texas corn production environments. The deployment of corn hybrids with herbicide resistance genes and Bt genes for insect protection starting in the mid-'90s were additional important genetic tools to reduce aflatoxin risk in corn across South Texas. Other genetic advances concerning drought response were also important. Corpus Christi Station pathologists, entomologists, and other scientists were involved in ongoing evaluation and investigation of these new and evolving technologies since their introduction in the mid to late 1990s. Research was conducted on the stations at Corpus Christi and Beeville, but also at other off-station locations. The increasing complexity and superiority of different Bt genes, stacking of genes, other natural host genetic resistance to insects and other stressors collectively help to reduce mycotoxin risk in the coastal bend of South Texas. This is sometimes coupled with other aflatoxin reduction management approaches like the deployment of atoxigenic strains of Aspergillus flavus.